Off you go. Welcome to the second video of our series designing this GPS-guided autonomous depth mapping boat designed to search, explore and map the underwater terrain. In the last video we put the boat out on the canal and the river, we tried the new hulls and tested the new camera. We discovered some design faults and some improvements that we need to make. In this video we'll be changing the hulls once more and upgrading the propulsion. The plan is to make it more powerful and much more quiet, and honestly I'm quite excited to see what happens. We're going to have some threaded inserts here and here and put in some bolts through these points. Now we're going to be filling the hull with a 2-part polyurethane foam. Now I've been told in my last video I can't just use expanding foam, so this time I've used a purpose-built marine buoyancy foam. Before it starts expanding, we're going to put the lid on and glue it in like so, and put some pieces of paper or plastic here so that when it overflows it doesn't spill out, it just spills up. Absolute pure chaos, don't ask any questions. So we're going to start by building the hull. Now to put it in context, this is the hull that we have now. This is the hull that we started with, and this is the hull that we're upgrading to. As you can see, again, it's quite a lot bigger. And as I said before, a much more traditional shape. There's some neat features with the way that this works, and I'll show you as I build it. It's only about 12 or 13 degrees outside at this time of the year. This 2-part foam needs it to be kind of an ambient temperature of about 20-21 degrees. So we're going to have to do it inside. So we're going to be cautious, we're going to have the window open, we're going to have the air purifier on next to it. But honestly, I have absolutely no idea how this stuff works. I know it's for buoyancy and I know it's marine grade. Plan was to fill up each of the hulls with a small amount and kind of build it up in layers. So we're going to start off by doing that, and then we get to see how the kind of foam reacts. But I honestly can't imagine it all going well. Unfortunately, we're just going to have to see how it goes, I think. So we're probably looking at about 150 grams of one and 180 grams of the other. And I guess we'll start with that. I'm using more than I thought I would. Right, I definitely think I need to pour some of this in the other. This isn't a fun game. The thing I'm thinking of here is where the lid's got to go on, but I can always sand or chisel it away a bit. Absolute pure chaos, don't ask any questions. So we've got some good news and some bad news. So 5 of the hulls were fine, they all worked out well. Basically, when you get the combination of heat and the expansion, it's quite an aggressive expansion, so it kind of tries to push the plastic. Unfortunately, we've got a small amount. We can resolve that other than this one. This is the one hull that did not survive at all, and it swelled too much and the plastic got pushed apart from each other, and we're just going to reprint that and try again. So what I'm going to do is I'm going to print the replacement hull, clean all of this up, and we can start assembling it. Right, so I got so fed up with how badly these middle bits printed that I just printed 2 new ones. We're just going to try again, but in a different way. So what we're going to do this time is we're going to actually glue all of these round first and then fill it up with the foam. In hindsight, that's probably what I should have done with all of the hulls. Right, so what we're going to do this time is I'm actually just going to weigh the liquids within the hull. This is what we want. It's just kind of like baking a loaf of bread. I'm a little worried about how much is going to come up again. The calculations are a bit, well, hopefully a bit better this time, but we can only see. So while that one is expanding, we now can remove these little things that I've put in just before it hardens too much. See, that has worked a lot better. There is a little gap on this one. Ooh. Very satisfying. Right, so we've got all the holes filled with foam. Now they're pretty close in weight. One of these holes from the center is slightly more than the other. So I've tried to balance each side so it has an even weight. There's about 20 grams difference between the left and the right. We'll have to try and combat that with a little bit of extra weight on the lighter side. So the next steps now are to add these threaded inserts. So I'm definitely going to have to speed this up because there are 44 on this part of the hull. Finally, all the brass inserts are in, so we're going to join the holes together, and I'll explain how they join together, but you've probably worked it out at this point. Basically, we've got some nutserts in there, and we've got the connection in like that. Now, the reason for this, if we ever need to replace one part of the hull, we can, and it fitted on the 3D print bed, because like I said before, I wouldn't have been able to print it if not. So hopefully everything lines up. What we're going to do is we're going to just screw in everything ever so slightly so we know we can line up the threaded inserts before we tighten them up. Of all of the tools I've got, this size Allen key I don't actually have a bit for. There you go. One hull is complete. That's pretty solid. God, I don't want to say that again actually, just in case. One down. One to go. Well, there it is. Both the hulls are now assembled, which is very good news. Very happy of how it's going so far. I'm going to go away now and just sand them because that's a really boring part. For the next part, we're going to be adding these rails. So this is what will be holding the center part of the boat. As we spoke about in the last video, what we're going to be doing is adding these rails so we can change the center of mass on the hull. Unfortunately, to continue on with this hull, we're going to have to butcher the old one for the screws back. So I guess we remove all the screws on this one and say goodbye to this hull. As you can see, it's quite a lot smaller. It's a shame though, but it's for a worthy cause. Oh yeah, and I thought I'd say, in process of taking this apart, if you wondered how much of a design fault these joins actually are that we mentioned and we had an issue with in the last video, this is the design fault. Which reality is breaks way too easily. So I've scavenged some screws from the old hull, so now we should be able to start putting these rails on. Right, so the rails are now on. There you go. So that is one of the big segments of doing this next stage of boat. This is the rail that the actual boat is going to sit on, and this will be able to move so we can change where the weight is. And also, I think going to be really useful to be able to take this part off for transport. Now that we've got the holes sorted, we can start assembling the rail. So the rail consists of these blocks that fit into the end of the carbon fibre tube, and then these blocks which go over the whole tube. So what we've got to do is put some brass inserts into this block. This will go into the carbon fibre tube, and then you'll screw through those two holes into the brass rod inserts. We've got the brass inserts in and cleaned up. We're now going to do a trial assembly of these carbon fibre tubes with them installed. So we begin by really just lining it up like that. We then put the block in like so. So we've got it like this. And then in theory, it should just kind of screw in. A very solid block. And that's on a carbon fibre tube, so we should hope that that is a very solid connection. Right, so we've now done the bars, and we can demonstrate how it's actually going to go together. I'm hoping that it's going to all fit on the screen. We're not going to bolt anything in yet because, like I said, we need to unscrew one side of these to push the boat onto it. There you go. So these are the rails. The big thing is it's pretty heavy. We've now got the holes together, and we've got this part, which is the actual brain, which has got all of the electronics in. So we're upgrading the motors, but I think for now we're going to leave the 35 amp ESCs that are already in it. If we start to have heat issues, then I think we'll upgrade to 45 amps, but realistically we don't want to be using that much power anyway. Now before we put this onto the boat hull, I thought while we still have access to it, it'd be better to add the arms that host the motors first. On the first iteration of the boat, we had these mounted on the hulls, but my plan is to mount these to the main brain, and that way if we ever need to take it apart and disconnect it from the hull, we don't have to change any of the wiring. I've got Wago blocks inside here, so we shouldn't even need to do any soldering in order to switch these motors out. What we've got is we've got the motor mounted on this bracket. You've got this plate, which is TPU rubber. This fits into this part here, and the rubber comes through the depth of the holes slightly. We then have these screws with some rubber TPU washers, again with a slight guide line that comes through the bottom, through both of the pieces of rubber, and then into the hull. The goal of this is that this bracket doesn't ever come in direct contact with the boat itself. Instead, you have a layer of rubber at every point, whether it's on this side, that side, or through the hull, that prevents the screw from actually touching any of the plastic and prevents the plastic from touching the boat. This is to kind of try and limit and reduce the amount of vibrations. We're going to start by assembling these as much as we can and then attach them to the boat. So all we need to do really to prepare this, I'm actually going to start by ensuring that the motor is bolted in with all these connections and the bolts don't go anywhere near the coils of wire, because this is an outrunner motor. The mounting screws, if they're too deep, do have a possibility of hitting the coil. Right, so we've got both the mounts set up. So the next step is to join it onto the hull. we've got to be careful because we've got our GPS there. Right, so that is what we've got. And it doesn't hit the hull. It doesn't hit the boat. So at this point, I think, let's see how strong that is. Yeah, fine. Yeah. At this point, I think we're ready to attach it to the hull. So let me just clear up this stuff and we'll get there. Undoing this side of the tubes so we can feed that onto the tube. But we'll get there. So at this stage, it doesn't really matter whichever way I decide to face it, it will be the way that it goes. There you go. Oh, that is connected. It's not centered at the moment, but we're not too bothered right now. That's fine. We'll put these back in, starting to come together a bit. Right, it's got some weight to it. That is the beginning of it. Right, all the screws are in. Next step is to chuck the wiring in. Right, we've got our cables in the Wago blocks, so now to put the lid on and test it, I guess. Right, so we'll get our battery in. Cool. We've got the blades how we expect them to be. Now, which way are they blowing? Opposite. Are they both blowing opposite? Now we want them spinning opposite ways basically, because you want the blade to be bringing water away rather than into. So all we'll do is we'll swap two pairs out within it and another pair swapped. This is the advantage of these Wago blocks. They're rated to 32 amps. So realistically 32 amps between all three phases of the motor, fine. Nice. Seems to work. I was going to test this in the bath, but it won't fit in the bath anymore. So it's just going to be testing out on the water. Move this into the dead center and try and get the balance right, but I don't need that on film. And we're going to seal everything up, make sure all the bolts are tight and get to some water. If you've been watching this far, we're ready for a pretty exciting part. Right, so we've just gotten to a lake because I thought that as opposed to a canal and a river, a lake might be the best thing really to take the boat out on, but the weather doesn't look great. I'm not so worried about the slight amount of rain, but it's more so, will the boat be able to deal with the waves? It depends really from like minute to minute, but some of these waves that are coming in are quite big. Now, obviously, like I said, I wasn't able to test the boat in a bath, and we're not able to test it, well, we're not at a canal, so whatever we do, we're kind of saying, yes, it will be fine, and I'm not sure whether it will. The thing we don't want to happen is A, a motor cuts out, or B, it flips over. But this is where we're at. We're going to assess the situation and and see whether this is a wise decision really. I might do a float test here, just so we can see what it's going to be like, because the waves aren't that big here. We're starting our initial tests without it connected to the controller. This is just to see whether the boat is going to sit correctly in the water. We want to make sure that it's not sitting on one side and that it's not going to sink if it doesn't have the correct buoyancy. For this, I'm just going to begin putting pressure on one side, holding it down and seeing how much weight it takes, whilst also checking that there's no bubbles that are going to be released. As I said before, I couldn't test it in the bath, and I have to make sure now that it's not taking on any water into the hull. If it takes on water into one side, it could easily unbalance it and let it tip over. We're now just putting some shock on it and making sure that it seems stable. Right. Is it engaged? Do a little bit of a... At this point, I just want to make sure that the controller is actually controlling the boat and everything is going to react as it should be. I'm a bit concerned at this point that when I go out, it's just going to lose connection and slowly float away. Yeah, look at it hit the waves. I reckon it's a lot faster. Right, well, it obviously floats. Ooh. That's the only problem with it sitting higher in the water, is it bounces more.
Yeah.
Oh, I don't like it. Oh, look.
Oh, it's fucking spot on.
I think it feels like it's less stable than it is, actually. It's like it's less choppy, but bigger waves at the moment. Look at those. Ooh. Ooh. You see how much that hull came out of the water then? You want to just send it, don't you? That's the thing. But we can't at this stage.
I know.
Oh. It took the wave then, didn't it? We've just finished the first test and it actually handled the water a lot better than I thought it would. We've just gone over some checks, some tightness checks, and everything seems fine. There's no water on the inside, although you probably can't see very well, and there wasn't any water inside here. Of all of the time that we're testing, I imagine it's been out on the water at least 30-40 minutes, and it's only gone down 0.3 of a volt, so I don't think we really have an issue about battery life either. I'll have to try and calculate how long it would last based on that. But it has been fighting a lot with the waves, as you'll see. But the holes seem to stay buoyant and cut through the waves or stay over the top of the waves. And it doesn't look like one side's sitting lower than the other, so I don't think we're letting in any water. Yeah, happy days. I just showed you a part of telemetry, but we're not going to be doing waypoint missions today on this water. I don't think it's wise because I don't plan on jumping in after it if it goes haywire. I'm going to call that a successful mission. Next steps are to test it on some waypoint missions, maybe on some less choppy water first, and chuck the fish finder on the back so we can see some depths of where we're mapping. We still want to take it out on a lake, I think, because you have much more interesting depths within a lake, but we'll get there next. That'll be the next part.